In the beginning of the history of the atom, we had two, Aristotle and Democritus. Aristotle was the premier philosopher of ancient Greece, and wrote extensively of the arts and science. However, it was when the views of Democritus came into being, challenging the theory of matter being the elements of earth, wind, fire, and air, that Aristotle and many others rejected his ideas that particles called atomos were solid, indestructible, and invisible, and that they made up everything, different kinds for different things, sizes, and shapes. If we skip from 460 through 322 BC, we move to the 19th century and John Dalton. John Dalton helped usher in the development of the modern atomic theory. Dalton supported Democritus, but he revised Democritus' ideas to form Dalton's atomic theory, where matter is composed of extremely small particles called atoms, and that atoms cannot be created, divided into smaller particles, or destroyed. After Dalton and his theory came Sir William Crookes, of whom was working with cathode rays. Cathode rays were long glass tubes with a cathode and an anode at each end, with a beam moving through the tube, which were called cathodes. It was found later that these rays were actually a stream of charged particles. He noticed a flash of light within the tube that was found out to be waves of radiation traveling through the tube. This discovery opened up other scientists like Millikan and Thomson to find out more. American physicist Robert Millikan determined the charge of the electron in 1909. Millikan calculated the charge, which is -1, and through this he determined the mass of the electron at 1/1840, or 1/1840. 1840. Moving a little bit back to his contemporary, in the late 1890s, English physicist J.J. Thomson was working with cathode rays to determine the ratio of its charge to its mass. Thomson found out through experiments that really since the particles in the tube were lighter than hydrogen, the lightest known atom, that the particles are smaller than an atom, and thus the electron was discovered. This was a breakthrough that rocked the scientific community because it meant that the atomic theory of Dalton was wrong. Thomson wanted to explain the electron and how matter is neutral further from this, so Thomson introduced the plum pudding model. The plum pudding model demonstrates a sphere of positive matter amidst evenly distributed negative electrons. However, this was trumped by Thomson's student Ernest Rutherford in 1911. Rutherford introduced the gold foil experiment, in which Rutherford and colleagues launched alpha particles at gold foil. In theory, the particles should not have been altered by the electrons, but in reality, particles are greatly affected, and when they bounced off the electrons, the particles sometimes launched themselves back at the source. This disproved the plum pudding model, and in turn, Rutherford speculated that the atom was made of mostly empty space, but in the center was a dense core, called a nucleus. However, this new model could not account for all of an atom's mass. Bohr, a student under Rutherford, proposed a new model in 1913. Bohr utilized the ideas of both Einstein and Max Planck with quantized energy, where only certain values are allowed, and proposed that atoms have certain energy states, the lowest being a ground state. Based upon orbits and like for energy, Bohr designed a way to tell the energy of an atom through its energy levels. However, Bohr failed to explain this concept outside the first few rows of the periodic table, and further did not explain the chemical behavior of atoms. But Bohr laid the groundwork for scientists such as French graduate Louis de Broglie in 1924. De Broglie proposed that perhaps the particles are waves, much like how light is a wave and a particle. Developing the de Broglie equation of wavelength equals h over mass multiplied by velocity, he helped further the next coming and the final scientist in the search for the modern atomic theory. Erwin Schrodinger concluded over the atomic model by coming up with a model that is used today, the quantum mechanical model of the atom. A complex model, it explains not only where some electrons may preside, but cannot be determined as proved by the Heisenberg uncertainty principle, but it also explains the chemical behavior of atoms, something which Bohr's model failed to explain. Schrodinger used the wave-particle theory as proposed by de Broglie, and when applied, it made hydrogen's electron a wave. And thus, from 400 BC to 1926 AD, the atom and its subsequent theories have all built up to the quantum mechanical model, thus concluding thus far the history of the atom and its structure. Good day to all, and thank you for watching.